this is Joy Varghese from Dean Public School, Navsari. Now this is video number 15, topic 10.7.1c, that is chapter 10, haloalkanes and haloarenes. Now in this we are going to study about stereochemical aspects of nucleophilic substitution reaction. Now before going to learn this stereochemical aspect, we need to learn some basic terms in basic stereochemical principles that comes in stereochemistry. What we say, the first one in this is optical activity, second one is chirality, third one when we say it is what we already discussed, retention of configuration, that we have studied in SN1 mechanism, that is stereochemistry of SN1 mechanism, inversion of configuration, that is SN2, already discussed this both things. Okay, inversion means kagado thai gyo, what we call, and the fifth one basic is resmissation. So first we will start with optical activity. Now when we talk about this optical activity, now what is this optical activity? That is nice given in your textbook when we say, see. Now in this case, these 5 things what we are going to study, with these 2 we have already studied here. Now optical activity, plane of plane polarized light produced by passing ordinary light through Nicol prism is rotated when it is passed through the solution of certain compounds. Such compounds are called optically active compounds. Now when I talked about this everything must have went above your head. Now when we talk about your ordinary source of light, the ordinary source of light beams vibrate in all directions, but when it is passed through this polarizer is the one which convert ordinary light into plane polarized light, means in one direction it will vibrate, right? Now how this plane polarized light is made, that we will study first, and then I will explain optical activity. Okay, so now in this case, see, when you see this figure, this is our ordinary source of light. This is 2 prism kept, this right angle prism, this is Nicol prism. So when a ordinary source of light, a ray, is passed through this Nicol prism, it will start vibrating in a single plane, what we call, that is straight or like this, what we say. So plane polarized light, it has now changed, means ordinary light change into what? Plane polarized light. Now if that compound, if you put a compound in this polarimeter, this is called polarimeter. Okay, it's a hollow tube, metal tube, in which you can feel the compound, or if you don't understand, a chemical. So if you feel a chemical and you pass this plane polarized light through this polarizer, this is polarizer, whole apparatus, we call it as polarizer, this whole apparatus. So when you pass this plane polarized light through this sample, this chemical containing tube, what we call it as polarimeter, what will happen? This plane polarized light will rotate in some direction. Now if you see in this case, it has rotated toward which side? Right. Now if it rotates toward left, we call it as left rotation, what we call, but for this particular term is given, means right side it will rotate or left side it will rotate. Okay, so the compound which rotate this plane polarized light is called optically active compounds. What is the word we discuss now? What is the word? That is the compound which rotate the plane polarized light. Now how this plane polarized light is being made? By passing through a polarimeter. Okay, Nicol prism we use here. So compound which rotate the plane polarized light. Now if it rotate towards right side, we call it as dextrorotatory. What we call it as? Dextrorotatory compound, right? Now dextrorotatory compounds, they have a symbol. Biology student must have studied also. We use a small d, or we use a plus sign like this, right? Which sign? Plus sign for right side rotation. Dextrorotatory compound we call it as, okay, or small d is the symbol. Now if the plane polarized light is when passed through polarimeter and it rotates on which side? Sorry. If it rotates on left side, which side? Left side, we call it as levorotatory. Clear? So left side you can remember levorotatory, right side dextrorotatory. Okay, this is levo, left for levo, right? Compound we call, and the symbol is small l, that is lowercase, or minus sign is used. Understood? So which are the optically active compound? The compound which rotate the plane polarized light. How is plane polarized light made? So it is made like this. How it is? Source of light, that is our ordinary source of light, bulb or whatever you say, pass through Nicol prism, it will change into plane polarized light. If this plane polarized light is passed through a sample tube, sample in which we fill the chemical, and if this plane polarized light is rotated towards right side, we call it as dextrorotatory, towards left side we call it as levorotatory. Okay, and the symbol we said for right side and left side we have seen, right? Understood everyone? Okay, now this same thing is given in your textbook. So optically active compounds, now I think it will be clear to you. Plane of polarized light produced by passing ordinary light through Nicol prism is rotated when it is passed through the solution of certain compounds. Such compounds are called optically active. If it rotates, optically active. The angle of rotation in which plane polarized light is rotated is measured by an instrument called polarimeter. If the compound rotates the plane polarized light towards the right, then right means clockwise direction, we call it as dextro, Greek for right it is, and the D form, or it is indicated by placing a positive sign, right? Now if it rotates towards which side? Left. Left means anti-clockwise direction, what we call, and the compound is said as levorotatory. Levo, Greek word left. L form is written and negative sign is placed before the degree of rotation. Means degree of rotation means what? If it is rotated 90 degree and dextrorotatory, we write plus 90 degree, or we can write D 90 degree. Like this we can write. Understood? Then if it rotates, this is for what? Right side. Right? If this much degree it is rotated. Now suppose 60 degree you take, then 60 degree right side rotation. And if it is written 60 degree and minus sign is written, it is the meaning, what is the word? Left side rotation. Which side rotation? Left side. You understood everyone? Right? So this such plus and minus isomer of compound are called optical isomers, and the phenomenon, this phenomenon is called optical isomerism. Understood? So what is optical activity? I think it is clear to you now. Okay? Now the next part. Okay. Now the next part is chirality. Now chirality, when we say, I think you must have heard about. Now suppose, what is chiral compounds? So now suppose if I write A like this, A, right? And this is a mirror, what is being used. What is used? Mirror is used. What will be the mirror image of A? I think it will be A only. Suppose if I write D, and if I use a mirror here like this mirror, what will be the mirror image of D? It will be like this, right? Now this A, if I want to superimpose means if I take this A and put it on A, you will see the you can see the image will be like this. It will easily superimpose on each other. What is this word? Superimpose. Superimpose. The word is ek ni upar ek muke em tak. It is possible, but in this case it is non-superimposable. Imposable. It is, what is the meaning of the word? If I keep this D on its mirror image, you will see one D is like this already on this side, and this D also I put like this, it will be like, means it is non-superimposable. So the chiral compounds are the one, there are two conditions for compound to be chiral. Condition number one, okay, is asymmetric carbon must be there. What must be there? Asymmetric carbon. Now what is this? This I will explain next now. And second is non-superimposable. What is the word? Non-superimposable. Right? Now what is the meaning of this word? Asymmetric carbon means if I take like this one carbon, if I write like here, you can see here carbon, right? On this one H is there, here one OH is there, clear? Here one CH3 group I will take, and here I will take one another group if you want, C2H5. That is what? This is ethyl group, this is your methyl group. Now if you see, in this case all the groups are different, right? This is also different, this is also different, this is also different, and this is also. So we can call this carbon as which carbon? Asymmetric carbon. Which carbon? Asymmetric. So which are the two conditions for the compound to be chiral, compound conditions for compound to be chiral. Okay, which are the two conditions? First condition is it must have an asymmetric carbon. What is the meaning of the word asymmetric means? Asymmetric means all the substituents must be different. Then only we call this carbon as a asymmetric carbon. Second condition, non-superimposable. Now non-superimposable means what? If I take a mirror image of this, what is the mirror image of this? OH will be here, that is H. O will be like this, C here, H. Here will be C2H5 and here will be CH3. Now if I take this image, this one, and put it on the mirror image of this same, here it will be non-superimposable. Second condition, this compound is asymmetric. So we can say that both of these conditions are satisfied. Therefore the compound we call it as a chiral compound. Which compound? This compound can be called as a chiral compound. Understood everyone? So what is chirality means? Two conditions for compound to be chiral, which is that asymmetric carbon must be there and non-superimposable. Non-superimposable, this part is clear to you, right? Now we will see through the example what is given. See. Now you can see here in this case, what is written here? An object or a molecule which is not superimposable, non-superimposable word also you can use, on its mirror image is called a chiral compound. That what we already studied. Then chiral objects have what? Non-superimposable mirror images, and a chiral object has achiral means that two condition, out of that any one will not be satisfied. That is what we call it as here. This, can you see this two condition? Any one, if it is not satisfied, we call this as a which compound? Which compound? Achiral compound we will call, right? So everything is written here. You can go through this. Look here what is written here. The word chiral, that is chi and ral, a word derived from the Greek word chir, means what? Which means hand, and is used for the object which have right hand and left hand forms. The general property of handedness is called chirality. Better you go to this topic. I think I say this one is important. That is, I think you understood, no? This part what we have seen here. Can you see this? If it is superimposable, we cannot call that compound as chiral, because what are the conditions for compound to be chiral? That is non-superimposable, right? Now two conditions for compound to be chiral. What are the two conditions to be chiral? Asymmetric carbon, and another is non-superimposable. Okay, 1 minute. Now in your textbook, if you see page number 306, very nicely it is being explained that two conditions. What is these two conditions? Chiral molecules are optically active. Optically active means it will rotate the plane polarized light in two directions. What is the word? Chiral compounds are optically active, while the objects which are, what is the word? Superimposable on their mirror images are called, what is the word? Achiral, and these achiral compounds are optically inactive. So which are optically inactive? The achiral compounds, right? Now I already discussed which are the two conditions for compound to be chiral. The one is, what is the first condition? What we discuss here? The first condition is, what is the first condition? Let me know. Conditions for compound to be chiral. Okay, not chiral, chiral we have to say. The first condition is, it should contain an asymmetric carbon. Asymmetric carbon means all the substituent must be different. And second condition, non-superimposable. These two conditions, if it is satisfied, you can say that a compound is chiral. If these two conditions are satisfied. If first and second condition is not satisfied, anyone or both condition not satisfied, clear, satisfied, then it is called achiral. What it is called? Achiral compound. Achiral, you can write like this also, achiral compound, right? So this is the topic. First one was what we call it as optical activity, in which we have seen right side rotation, dextrorotatory compound Dn plus, left side rotation, it is levo for left, you can remember, and plus or minus sign, D or plus sign for dextrorotatory, right? How to change our ordinary light into plane polarized light to pass it through a polarizer or polarimeter, okay, in which nickel prism is used, okay. So in the next video I will be discussing about the resmissation. What is the word? Because this retention and this we have already discussed, right? Inversion of configuration also we have discussed, right? So resmissation is the next topic in the next video, because this video will become very lengthy otherwise, okay. Thank you.